I'm your host, Michael Callahan, and wherever you might be now, this is where we go next. Dr. Alina Chan is a postdoctoral fellow with a background in medical genetics, synthetic biology, and vector engineering. At the Broad Institute of MIT and Harvard, Dr. Chan is currently creating next-generation vectors for human gene therapy. During the COVID-19 pandemic, Dr. Chan began to investigate problems relevant to finding the origins of the SARS-CoV-2 virus, and in parallel, spearheaded the development of the COVID-19 CoV genetics browser for scientists worldwide to rapidly track virus lineages and mutations by location and date ranges of interest. Alina, thank you for joining us today.
Thanks for having me on the podcast.
Oh, it's my pleasure. Now, to set the scene, for months, Facebook has had a ban on posts that claimed COVID-19 originated in a lab. But in late May, Facebook reversed that ban, following a call from the Biden administration to investigate whether the virus was possibly released from the Wuhan Institute of Virology. But many scientists, such as yourself, have been investigating this very theory for more than a year, and you're actually in the process of writing a book about the search for COVID-19's origins. And so I'm incredibly excited to discuss that with you today. But before we get into the meat of our conversation, which is your investigation into the origins of this virus, I'd love to learn a little more about what you're working on at the Broad Institute, quote, creating next-generation vectors for human gene therapy, end quote. So what does vector mean in the context of gene therapy? And for the listener, what would be some practical applications that technology you're working on could be used for in the future?
So gene therapy is a form of medicine where you're restoring a healthy version of a gene, so part of your blueprint, into a patient who might have a rare disease. And these diseases that are being targeted by gene therapy tend to be very difficult to treat with regular therapeutics or drug compounds. So by a vector for gene therapy, what I mean is the delivery system for giving a healthy gene back to a patient. And in this case, it is a virus. So it's a virus that can infect human but doesn't cause any disease. So when you hear about gene therapies, most commonly, these would be using viruses that are not pathogenic to humans.
I understand. Are there examples of that technology where you use a virus that's not harmful to humans to enact gene therapy? Is there an example like that happening today that is actually in practice in medicine?
Yes, and I don't want to do too much product placement. There are now gene therapies that are just past clinical trials, or at least in the middle of clinical trials. These gene therapies, they tend to be applied to diseases that are really difficult to treat with traditional medicines or even surgeries. So these tend to be neurodegenerative diseases such as ALS or SMA, spinal muscular dystrophy. So these diseases, they really benefit from gene therapy because you can target the gene therapy to specific parts of the body that benefit from this cure rather than the whole body receiving a drug that is not even specific to the disease.
One thing that I like to do, and I tried doing this with Dr. Gandhi when I brought her on to discuss the COVID-19 vaccines, is whenever we start talking about kind of like heady scientific stuff, or at least stuff that feels rather heady to me because I'm not in the scientific field, I like to try and ground it into something that's concrete so that the listener, and really myself, can have something to kind of grab onto, right? So I appreciate you kind of taking that research that you're doing and allowing us to kind of understand how it's being used today. So thank you for that. But let's talk about the COVID-19 genetics browser you've had in development. You've been leading development on. The average listener may be familiar with the phrase COVID variant. Now, there's a UK variant of the virus known as B117, a South African variant, B1351, an India variant, and so on. So am I correct in thinking that variant is akin to lineage in this context? And if so, how are scientists putting covidcg.org to use in their work today?
Lineages and variants are a bit different. So lineages tend to speak to a whole branch of variants. And sometimes the use of the word variant can vary from scientist to scientist. So typically a variant is a version of SARS-CoV-2 in this case with a particular set of mutations. But lineage can be multiple variants in one tree together and in one batch together. So with this browser, the URL is covidcg.org. You can track all of these lineages and variants across time and across any country of your choosing. So there's a really friendly user interface where you can select the time range, the date range of your interest. Let's say just in 2021, you can pick the countries that you're interested in, the geographic range, and then you can even pick the variants and lineages that you're interested in and track these over time and space.
So, just to quickly follow up there, what would be an example of something that a scientist is using that site for in their day to day research or work on tracking down the origins and the lineages of COVID-19?
So to give an example, let's say you're very interested in this new variant that's coming out of India and dominating in some places now. You can use covidcg.org to track where it first appeared and track in each country when this variant is first detected. So it's quite useful because you can see how much time this variant has spent in a particular country, whether it's growing or decreasing, whether it's changing, mutating. So these are questions that many scientists want to answer, especially scientists who are developing diagnostics or therapeutics or vaccines that target certain parts of the virus. And so with more than 1 million SARS-CoV-2 virus genomes available on a database called GISAID, it's really difficult for the lay scientists to analyze that data in real time. So this resource, COVID-CG, it does that for you. It's really easy for you to, within minutes, generate hypothesis, and then later you can do more in-depth analysis on your own.
That makes sense. Is the site also used as a way for non-scientists or people in the scientific community that aren't necessarily doing that exact kind of research to enact kind of logistical triage? Because I know that some of the variants are more deadly than others, some are more transmissible. And if you can track where these lineages are and where they're spiking, let's say, does that also enable people who are using this site to kind of track where those spikes are happening and respond appropriately?
Yes, it does. So I think a lot of journalists and also public health experts have started using the site, and from many different countries. You can use it to see what the sequencing efforts are like in each country. That's one common use of the site. And a lot of them like to see which country is doing the best in terms of the number of virus genomes sequenced and shared on the database. But you can also track spikes or peaks of the different variants that are in each country. But I think the site is really the most beneficial for scientists who want to be able to analyze all of this, like more than 1 million genomes at once. So other sites tend to subsample, so they only pick a few examples and you kind of get a big picture, but you don't get to analyze it comprehensively. And COVID-CG is the opposite. You get to interrogate all of these million plus genomes at once.
Wow. Well, that sounds like a hell of a resource, and it sounds kind of one of a kind in its field compared to the other resources available to scientists like yourself. So let's jump into discussing the potential origins of the COVID-19 virus, the kind of very reason I brought you on today, and how those origins may affect both the global stage and the future of viral research in general. A lot of the noise around the lab leak theory is the idea that China is kind of especially, quote, to blame, or that it needs to be punished if the virus did, in fact, leak from one of its labs. But during an appearance on the Mehdi Hassan show, you said, quote, "This is not a blame game. This is a question of possibly the most important question of our lifetimes. Where did this pandemic come from? And how can we stop this from happening again?" End quote. And I think that that's absolutely spot on, Alina. And so to start us off, I'd like to ask you a question that you've said you'd prefer scientists be asked. What don't you and your peers know about this virus and its origins? And what evidence are you currently waiting on?
Yeah, there's a ton of stuff that we don't know about this virus, and most of it is not due to technical challenges, but social challenges. That's because a lot of the information and data lie inside of China. And so these have to do with the earliest cases of COVID-19. We don't know who they are. We don't know what exposures they had to either a laboratory or a market. We don't know how early some of these early cases were. We don't have access to banked blood donation samples in Wuhan City that predate the outbreak. So we don't know how early the outbreak actually started. We don't have access to the animal samples across China, especially those from the market. We don't have information about even the animals that were sold at the market and what animal samples were collected and tested. So there's a ton of information that China could share and allows international experts to go in and investigate.
Yeah, that makes a lot of sense. So then, considering all the limitations that are on scientists such as yourself and other researchers who are trying to understand the origins of this virus, what do we know right now? You know, and one of the reasons why I want to ask what don't we know, right, is because I think that you made a very important point on Twitter a couple weeks ago about how oftentimes when a journalist or a podcaster such as myself will ask a scientist, what do we know? It gives the scientist less flexibility, or it can hold them to account when they don't necessarily need to be held to account if they need to update their information later on, right? So understanding that and understanding the background of my initial question, what do we know right now? And by we, I mean people such as yourself who are researching this day and night. What do we know right now about where this pandemic came from, and how do our initial theories of Wuhan wet market origin look right now?
Yeah, so just to emphasize that point, when scientists are asked for a likelihood estimate, they often want to give you an answer because scientists love being able to answer questions. So they will sometimes force themselves to give you a number, even if they're not confident in that number. It's unfortunate, but it's human nature, and I think it's in the nature of scientists. So that's why I advise journalists not to ask for likelihood estimates in the absence of evidence. So it's right now, there's so little evidence to go on, there's so little we know that to come up with some prediction of how likely a lab leak is versus a natural spillover, I think it can be constraining for scientists and it could actually lay a trap for them. So that in the future, if new evidence arises, they might be too embarrassed to backtrack and change their estimate. In terms of what we know, there's very little. So we know that the outbreak was first detected in Wuhan City in China, that this is very far out of the spillover zone of SARS viruses, and that there is a lab in the middle of the city that is possibly one of the largest collectors of SARS viruses. So those circumstances make it possible for a lab leak to be true, and on top of a natural spillover at a market.
Now, you've said previously, quote, "We've searched for more than a year for an intermediate host for the animal that carried the immediate precursor for the virus before it jumped into humans, and we have not found it. The current evidence is all circumstantial, and it is consistent with both a natural and a lab origin of this virus," end quote. I believe you said that on the Mehdi Hassan show. So I have kind of a couple questions there. Who has been leading the search for this intermediate host, right? You've said moments ago that the main challenges for scientists and investigators right now are social challenges, a lack of cooperation from the Chinese government. So has there been any partnership with China? Are there researchers from multiple countries on the ground in Wuhan at all? Do we have any data that's coming from either unofficial or official channels within the Chinese government? What's our communication like with Chinese researchers in the area right now?
Last year, the World Health Assembly, they made a resolution asking the Director General of the WHO to investigate the zoonotic origins of this virus. And that was in July. So to do this joint study, to find the zoonotic origins of this virus, they had to team up with China. So China is a sovereign nation. You can't just waltz in there with an investigation team and start sampling animals and humans. So they agreed by November of 2020, and they published their plan for their joint study, that China would do all of the research. And then a group of about 10 international investigators would be allowed into the country to discuss the outcomes of those research. So all of the groundwork was done by Chinese scientists.
And what were the results of what happened in November of 2020?
So November 2020 was when the terms of reference, so the plan for the study, were published online.
Okay.
It was only in mid to late January that the team got to go in, and they had to be quarantined for 2 weeks. So during that time, they had meetings with their Chinese counterparts, remote meetings. So they were all trapped inside their own hotel rooms for 2 weeks. And they discussed what the Chinese scientists had found. And then in the next 2 weeks after that, they got to visit some of the sites that were important, but also an exhibition to show them how well China had done to counter COVID-19. They've also brought to see like a freezer storage area, because China had this hypothesis that the virus had first been introduced to Wuhan City through the cold chain. So possibly through imported cold chain. So this was a theory that China really favored because it placed the origin of the virus outside of China. So after the visit, they gave a press conference and they said that the most likely origin scenario was one where an intermediate host, so not a bat, but an animal more similar to humans, had passed the virus into humans. They basically ruled out the lab leak hypothesis by calling it extremely unlikely, saying that they would not follow up on this hypothesis. And they said that it was also possible and likely that the virus had been introduced through the cold chain into Wuhan City.
When you say the cold chain, does that mean in the way that humans pass colds to one another, that somewhere along the way, or no, am I misunderstanding that?
No, I should explain that more. Yes, the cold chain is possibly one of the most fantastical ideas I've heard, aside from SARS-CoV-2 emerging from a meteor. So the cold chain means that a frozen fish or frozen piece of meat was transported over long distances into Wuhan City, where a person then proceeded to get sick from touching that frozen piece of fish or meat.
Okay, I understand. I'm glad I asked, because I don't think I would have automatically known what that meant. Now, look, I know China gets a lot of flack for obviously wanting to deflect any culpability it has for the release of this virus, let's say. But I think that some of that is probably rooted in the idea that if this was potentially an accident, right? Like if it did leak from the Wuhan Institute of Virology, on the back of someone's shoe, or someone accidentally got infected and then passed it along to a loved one, or et cetera, right? I guess I'm struggling to understand why China feels it's in its best interests to kind of keep the lid on this, when ultimately it would behoove their country and their people, in addition to everyone around the world, to understand exactly how this virus started, even if that means it started from somewhere within China or Wuhan specifically, because then that means that it would be less likely to happen in the future and affect its own citizens, not to mention the global community. So beyond, I guess, what kind of the obvious reasons are for why China might be reticent to discuss this with the global scientific community, let's say, isn't it in China's selfish best interests to get to the bottom of this and allow scientists and researchers, both within its own country and globally? I guess I'm struggling to understand, even from just a selfish point of view, why China is resistant to, for all of us, just get to the bottom of this so we can all make the world better. Does that make sense?
Yeah, I think from my point of view, China has many reasons for not wanting the virus to be seen as coming out of China. So one thing that's already happened is a lot of people, including politicians, calling for reparations. Can you imagine the trillions of dollars that China would have to pay up if the reparations claims went through? So right now, people seem to not want the reparations if it came from a natural spillover at the market, like a natural transmission of the virus from animals to humans. But it seems that if it came from a lab, then people would push for reparations. So I could see financially why China would not want to show that this virus came from their country, whether even natural or from a lab. The other parallel that I've seen being drawn is that this is kind of like China's Chernobyl. So it could have a destabilizing effect on the trust of the public, the Chinese public, in their own government. So for them, it's better to see the doubt that this virus was introduced to China by an enemy state, rather than China made a mistake and now its own citizens are suffering from the risk of biohazards, like really dangerous pathogens.
Yeah, I can understand, especially considering the date that we're recording this on right now, June 5th. I can especially understand if China is reticent to create distrust or animosity within its own population, right? I can get that. It historically tracks. But in terms of the reparations hypothesis, I'm not sure I quite understand that. One, because let's say Chernobyl, right? We could go to Fukushima instead. The radiation from Fukushima drifted as far as the California coastline, right? So the radiation from that event affected not just the local Japanese residents, but also the global population. And yet no one was clamoring for reparations from the Japanese. I guess I'm not sure why an accidental lab leak would necessarily prompt a call for reparations, especially considering that there's a precedent for a SARS virus leaking from a lab before. That a previous one leaked from a Chinese lab somewhere between 4 and 6 times. I think I've heard you actually quote that number. So I was wondering if you could expand on that a little bit. What SARS virus specifically has leaked potentially 4 to 6 times? When and where did this leak happen? And how did we come to find out that there were leaks in the first place, especially considering what we've just talked about with the Chinese government? How did we know that a previous SARS virus, not COVID-19, but a previous SARS virus, leaked from the lab if China seems so reticent now to even investigate a similar theory regarding COVID-19?
So I think this challenge has to do with the scale of the damage. So with Fukushima, there might have been some radiation passing out into the ocean and hurting some fishermen and the livelihoods, and also floating to the shores of California. But that cannot even be compared to the scale of this pandemic. So it's kind of like the difference of someone bumping into you in the streets versus someone like mowing down your house with a bulldozer. So there's some countries now that are in so much trouble because of the pandemic, like India and Brazil. Lots of developing nations have not been able to respond to this the same way that the US and the UK, for example, have been able to respond. Even in the US, it's caused tremendous amount of economic damage and also just had a huge emotional toll on everyone in this country. So this cannot even be compared to what happened in Fukushima. With the first SARS pandemic and the times it spilled, it was already the first SARS pandemic, which was natural in origin for sure, that had already tarnished China's reputation. There was even a cover-up then. So the Chinese government, when the WHO inspectors were finally allowed to enter Beijing to get a hold of the situation, they hid patients inside elevators and ambulances, and they drove the patients around the city until the WHO inspectors left. So even for a pandemic of that size, only 9,000 people were ever infected, up to 9,000 people-ish were infected in that pandemic. there were already attempts to cover up to try and lessen the scale of how bad the infection was, the outbreak was in China. With the lab leaks, it had spilled one time in Singapore, one time in Taiwan, from a BSL-4 laboratory, the highest biosafety level, and then at least 2 to 4 times in a single institute in Beijing. The reason why these were detected was because the first case in Singapore, he had gotten pretty sick and he went to the hospital and they were on alert because this was at the end of 2003. People were still alert for SARS cases. So they diagnosed him pretty quickly and they traced it back to the lab because he was a scientist. The Taiwan one was similar, but this man had taken a trip from Taiwan to Singapore and back and then developed symptoms. And he hid in his house and he got progressively sicker until his father threatened to kill himself unless his son went to report it at the hospital. So when he reported at the hospital, a whole bunch of people had to be alerted, but they didn't alert the people on the flights that he had taken. So again, just a different sense of risk assessment being apparent here. With the cases in Beijing, actually only one had been detected, but only more than a month after they had developed symptoms. And this was, if I'm estimating correctly, because this researcher had gone into a very far away city. So she had gone from a lab in Beijing to visit her hometown in Anhui through a long distance train ride. And then she got sick, I think, there. And then she went back to Beijing to get treated. And over there, she infected a nurse and her own mother. And then she and her mom took the train back to the hometown. And it was the nurse who got sick who was diagnosed with SARS. So her mom later died, but the nurse by then had infected multiple other people. And in that whole saga, about 1,000 people had to be quarantined. So this person had taken multiple trips back and forth, had not even been diagnosed. The person who was diagnosed was the nurse who was treating her. So these things can really get out of control. And with SARS-CoV-2, it's a virus that's extremely sneaky. We've seen that it can incubate for up to 2 weeks in people. And in a lot of young, healthy people, you don't even see symptoms or they're very mildly symptomatic. So nothing you would go to the hospital for. So it is a pretty prime candidate for a lab leak.
Yeah, it definitely sounds like it. It's not like the fictional SARS virus from Contagion, let's say, where between the time of infection and death, it's like 72 hours. I mean,
yeah.
Well, now I'm sort of struggling with any of my follow-up questions here, because if we have hit a brick wall in terms of cooperation with China, right? And there is, let's say, I don't know, an equal chance that internally the Chinese government either does or does not know where this virus originated from, right? Let's assume, because of the reasons you've stated, because of the fear of reparations, because of the fear of repercussions from their own citizenry, that even if China knew with relative certainty whether or not it had natural or lab-based origins, there are very few, if any, incentives for them to be honest with either their own country or the global community. So where does that leave us? I had a couple of follow-up questions, but your points have kind of obliterated them, right? Like, where does that leave researchers and scientists who want to get to the bottom of this? Because as you've said during a recent interview with NPR, quote, "Our lives depend on finding out how this virus got started," end quote. But do we have any chance in hell of actually finding out how?
Yes, we actually have a lot of opportunity to find out how this happens. And many of those leads are outside of China. So China did put down a gag order pretty quickly after the COVID-19 outbreak was detected. But before then, there was about a month of time when people inside of Wuhan and China were still communicating with people outside of China. And so it's essential for those people to be followed up with and just interviewed to figure out what they heard about what was happening in Wuhan, whether any of their scientist friends or doctor friends told them anything important about early cases. These are all still possible leads, but as time goes on, people tend to forget what they know, especially if it's a phone call rather than an email.
Right. So it really seems like the prime time to investigate this was within that 1 month window before China clamped down on information leaving China, let's say, and now. But that means that pretty much all of the information that we're going to have in the near future, and again, I say we, I don't actually mean I'm not going to be of any help in researching this. But when it comes to the people who are doing that research, I mean, it sounds like you basically have that 1 month window that existed, I imagine, in the beginning of 2020. And then kind of just everything that exists within that window, right? Because I'm imagining there are no scientists within China that are talking to anyone like yourself now.
Yeah, and President Biden made that point clear in his announcement as well. He said that it will always hurt us that we weren't able to get feet on the ground in the early months of the outbreak. And that's why I get kind of frustrated when I heard other scientists say that, oh, let's wait till we've dealt with the pandemic and then we'll investigate the origins. I'm like, no, the window gets smaller and smaller over time. So if you don't deal with the origins early, you will lose the chance. And we can see that in the case of SARS-1, that China had been extremely proactive with finding the source. So SARS-1, it broke out in 2003. Within 2 months of isolating this virus, they had found the intermediate host, so the animals that were the source of this virus passing it into humans. Not only that, but they found a whole population of people, the traders of the animals, people who found the animals and brought them to the city, and saw that this whole group of people had pre-existing immunity to SARS viruses, despite not displaying any symptoms of SARS. So they had found the way that the virus was getting into their city, and it was through the animal trade. But in this case, it seems like those steps have not been taken, or if they've been taken, they've come empty. So they haven't been able to find the way that these viruses have made their way from South China into Wuhan City.
To follow up on that, though, and obviously you are free to push back on any of these questions if I'm either going too far afield of what your knowledge base is, or if you don't feel comfortable guessing or hypothesizing, like, please let me know, because I don't know where the boundaries are unless you tell me. So it seems like China was, back in 2003, able to track down a fairly complicated back and forth path of this virus. I mean, the path that you were talking about to and from Beijing over many train trips, and then a nurse gets infected, and then a mother, and then all these different people. And they were eventually able to track down who it started with. I guess for me, and again, going back to all the incentives that you were talking about, or rather disincentives, that the Chinese government is dealing with in terms of how it is disincentivized from being truthful with the global stage and with its own people. How can we believe what you've just said they've said, right? And how can we believe that they don't know? If they've been so historically good at tracking down the origins of other SARS viruses, and they seem pretty confident that it at least is related to Wuhan, the area of Wuhan, pretty distinctly, how can we trust their announcements at that word, knowing how good they've been at tracking down similar SARS viruses in the past?
Yeah, so this question, it's really curious. Maybe let me rephrase that. So this question of where this killer virus came from, it's of high national security interest for China to know. It's not this situation where a new virus just emerged in our city and they don't give a crap where it came from. I mean, it's very dangerous for them, because if you don't know where it came from, it could come again, like next year. SARS-1, it spilled over in late 2002. And again, in the very next winter, it spilled over again and was detected. So for SARS-2, if you just leave it be without finding the origin, then the risk of another SARS-2-like virus emerging is always on the horizon. So it's important for China, where the first outbreak was detected, to know how exactly this got started. So some scientists have expressed this belief that China has not done some very basic checkups to figure out how this virus got started. They can't believe that China hasn't checked to see exactly when the virus started emerging in their city. They haven't checked banked blood samples. It doesn't seem like they've checked the market vendors for pre-existing antibodies for SARS-2. It doesn't seem that they've checked the very original suppliers of animals through the market trade into Wuhan City. So it almost seems that they have either found the answer, so they don't need to search anymore, or they've already found the answer and they're not telling us.
Yes, that last bit, that was exactly kind of my question, which is, again, like, it seems to the outside community that they haven't been doing research and following up, et cetera, et cetera. But historically, it seems like we have enough precedent that we can probably guarantee that whether they're telling us or not that they've researched it, I would imagine, based on the past evidence you provided during this conversation, and knowing China's incentives for secrecy, if it would make them potentially look bad, I'm hypothesizing that there is a not impossible chance that they know exactly where the virus came from, or have a very good idea and have done all the research and have done all the investigations, but have just completely kept it under wraps and have locked all that information away from the world for the incentivizations that you've laid out before us.
So China has tried to promote two different origin scenarios for this virus. One of them is the cold chain frozen foods scenario, where a foreign country, they like to say either in Europe or Southeast Asia, has shipped an infected animal frozen into Wuhan city, and that's where the first person gets infected by that frozen chunk of meat. Or the other one that promoted is a multiple origin scenario. So the virus emerges simultaneously in China as well as other places. So some other European countries, they've published studies saying that they've detected SARS-CoV-2 in their wastewater or in their patient samples as early as March 2019. So China really likes that. They like the idea that China wasn't ground zero for the virus.
Oh, I'm sure they do. Yeah.
Yeah. So when you have these options on the table, why would you provide data to show that the virus came from inside China?
Right. But there is a chance that they have that data and they're just not sharing it with us.
Yes, it's a possibility.
Yeah. And that's the tricky thing, right? Because there's a Financial Times magazine article that was published recently that said, quote, whatever U.S. agencies conclude, COVID-19 has already focused attention on biomedical research into deadly pathogens, much of which is subject to no international policing or oversight, end quote. And so I guess it seems like we're kind of at an impasse, right? Because even before the COVID-19, because there are labs like the Wuhan Institute of Virology all over the world, right? The U.S. has similar labs within its borders. European countries have similar labs. The lab that was in Wuhan is not distinct in that that kind of research is happening everywhere. But it seems like we don't really know what the international policing and safety standards are for really a lot of labs around the world, even outside of China. And so let's say we don't get further cooperation from China. Are there efforts internationally, at least, to begin policing standards at non-Chinese labs to ensure that at least this sort of thing doesn't happen outside of China ever again?
These efforts to step up biosafety and biosecurity, they are extremely grassroots. And I was very surprised to find that out after the pandemic had broken out. So this idea of there being some international body checking up on labs around the world, it doesn't exist. So there are some guidelines that are published, but nobody knows exactly what research is happening around the world. And we don't even know how many BSL-3 labs there are, or even BSL-2 labs. So these are intermediate biosafety labs. Like we don't even know how many there are and what they're doing. So this lab in Wuhan, the Wuhan Institute of Virology, the SARS-related coronavirus research they were doing were all done at BSL-2 or 3. So not at the highest level of BSL-4, but at lower levels of biosafety. And that really only came to light after people started looking very deeply into whether SARS-CoV-2 could have come from that lab.
That's worrying that we just simply don't know. I mean, I think it would kind of be akin to if we just had no set safety standards for nuclear reactors anywhere in the world. And yet nuclear reactors are some of the most heavily policed in terms of standards sources of energy that we have, because we understand the consequences of what would happen, whether it's Chernobyl or Fukushima or 3 Mile Island. We have examples of the consequences that happen when those sources of energy are not guarded with enough safeguards. So it's rather alarming to me, as kind of your average man on the street, so to speak, to understand that that is not really the case when it comes to institutions that are researching the deadliest pathogens that exist on planet Earth. I mean, help me out here, doctor. Why is that the case?
I think it might be because a lot of scientists have underestimated the risk of a pandemic resulting from a lab leak. So even with current situation, many scientists are still saying that this is such an unlikely scenario of COVID-19 emerging due to a lab leak that many have called it a distraction from the real investigation of the origin. So they say that it's distracting scientists from investigating the animal source, the zoonotic source. So it's that so many scientists cannot even bring themselves to believe that a lab accident could result in a pandemic. So there's no motivation to set down like an international body to put in the work to call for an international body to be regulating lab research.
Wow. That is legitimately shocking. I'm a little speechless, only because even the most basic and far less deadly things have redundancies and safety protocols. I mean, everything from airplanes to, as we just talked about, nuclear reactors and other kinds of power plants, basically anything that has the potential to harm a larger community has oversight, safety protocols, etc. It is just blowing my mind. It is legitimately blowing my mind hearing you share that information, because I mean, these labs have, probably viruses that I can't even pronounce or have even heard of. But Ebola, the bubonic plague, obviously
Yes, smallpox, fever,
smallpox. Yes,
yeah,
right? Like things that,
hemorrhagic fever.
yeah, pathogens that have basically been, because of vaccines, been eradicated from the general population, but that still exist in these research institutes. So, yeah, I don't want to linger on that too long, but I'm a little
Yeah,
blown away
it's
by
a
it.
scary thought. I think that part of the problem is that scientists are humans too. So as a scientist, you don't go to work thinking, wow, today I'm going to have an accident and then a million people will die. We can't operate like that. So a lot of scientists, they go to work thinking, there's no way I'm going to have accidents. I'm taking all the proper safety measures. And in any case, the bugs I'm working with, they are not that dangerous. So that's the daily calculation that a scientist has before going to work and working with, let's say, SARS-related viruses.
Yeah, I can understand that. I understand human fallibility, but I think it's that recognition of fallibility that necessitates the redundancies, right? And the oversight.
Yes, but I think it's missing.
Yes.
So that sense that my accident could kill a million people, that's missing.
Yeah. Yeah, it definitely sounds like it. When I mess up at work, I work in marketing. When I mess up at work, we miss a deadline. I don't have millions of lives on my hands. But one thing that did kind of shock me upon learning of the Wuhan Institute of Virology last year, when all of this was first going down, so to speak, was seeing how incredibly close it was to major urban population centers. Is this sort of thing common around the world or something specific to China? Is there any discussion happening now about moving these research centers at least further away from massive population zones to more rural areas and having the scientists and researchers live separated from the rest of, at least, let's say, major population centers? Is that something that happens anywhere around the world or something that's being considered in light of what's happened over the last year?
I'm just pulling up this website because there's this really great resource that's been launched recently. It's a collaboration amongst biosecurity experts. So again, these are all really grassroots initiatives. It's called globalbiolabs.org. And it's a web-based map of all the highest biosecurity and safety labs around the world. So the US has the most of it, but the densest area is actually in Europe. Because there's so many countries in Europe and so many of them have their own BSL-4 lab. That's why it's the most concentrated area. But the US alone has at least 12 of these BSL-4 labs. And China is trying to join the league. They're trying to build a BSL-4 lab in every single province. So it's kind of like this game where each country wants to show that they are keeping up. And even a tiny, tiny country like Singapore is planning to build a BSL-4 lab in the middle of its city. There's no area of the country where it's remote, but they're going to build a BSL-4 in the middle of the city.
Especially in light of what we just discussed about how there don't seem to be a ton of at least rigorous or standardized international safety protocols. That the combination of, and I'm not one for fear mongering. I had an entire episode in which I discussed how incredibly safe nuclear technology and nuclear energy is, because I don't find it helpful to unnecessarily fearmonger or overstate the dangers of something when something is oftentimes incredibly safe. So it's not that I think that necessarily these labs are like inherently dangerous. We don't have evidence that there have been just viruses just leaking from labs left and right. But from that Financial Times article, that bit about there not being international standards of safety protocols and international check-ins and just kind of some kind of standardized process in which we can ensure that these labs are safe day to day. That information combined with what you just said, which is that a lot of these labs, especially the one that you just mentioned in Europe, are in very dense population centers. It just seems like an unnecessary risk, which I am struggling to understand.
Yeah, again, I don't want to fearmonger, but when there is a risk, we have to deal with it, right? So
Yes.
Again, this all draws back to that original mentality among scientists that no way I'm going to be the cause of a pandemic. So scientists don't go to work thinking I'm going to cause a pandemic. So that's why I think there's such little international oversight. And also the fact that scientists tend to be very secretive. We don't tell everybody what we're working on right now. We tell people like 2 or 5 years later. So we keep our juiciest projects private until we're ready to share it with the world. So the idea of surprise inspections, the idea of having to hand over our lab records, like that is instinctively antagonistic to the existing scientific practice.
Yeah. Well, I want to make sure that we get into a couple other topics around the origins of this virus and what I imagine are some topics of interest relating to its origins to the listener. So you've said that COVID-19 is consistent with both a natural or a lab origin. And I understand that to mean that either scenario is equally plausible, right? Like that it could have either started in a natural setting or it could have started from a lab. A phrase that's relatively new to me that I've heard bandied about over the last couple months is something known as gain of function research. And in an attempt to be at least a partially scientifically literate host, I looked up the definition on Wikipedia and it says, quote, gain of function research is a term used to describe any field of medical research which alters an organism or disease in a way that increases pathogenesis, transmissibility, or host range, end quote. And so I know from previous appearances that you're especially cautious when discussing this specific topic. So I guess I'd first like to ask, is the definition of gain of function research that I just said generally correct as you understand it in your field?
So I think a lot of people, a lot of scientists have their own definitions of what is gain of function. But the definition that is relevant to the framework that guides funding decisions in the US is very strict. So there has to be a clear way for the pathogen you're working with to cause an outbreak, to cause a human outbreak. So it has to be a situation where you've given it powers to cause a human outbreak. And so there's a wide range of research that falls in the gray area that cannot meet this criteria of what gain of function research of concern is.
Gotcha. Okay, understood. So I guess we know that scientists have sequenced the COVID-19 genome. That's how we got the vaccines that are in our arms today, so to speak. So if they've studied the virus on a molecular level, a genetic level, if a natural origin is still plausible in your mind, and we know what the genome sequence is, we've studied the virus on a molecular level, this sort of seems to rebuke any sort of gain of function theories, if I understand it. I guess what I'm getting at, Alina, is would scientists be able to spot a human-altered virus while they were examining it on a genetic level?
No, we cannot. So there are some really obvious things you can look for, but nowadays technology is so good that you can build entire virus genomes without leaving a trace. So we don't have to, make some spectacularly unnatural looking virus. We can just go to nature and find what they have and put it together, and then it looks like a natural virus because natural viruses mix and match a lot and they recombine a lot. So it's hard for us to tell what has been unnaturally mixed and matched versus what has naturally mixed and matched.
I see. Okay. So it isn't something as simple as you could spot, oh, this part of the virus has clearly been synthesized by humans. It's not something like that. You're saying it would be incredibly difficult for someone examining the virus on even a molecular level to know whether or not it had been manipulated by humans.
Yes, I think there's been some hubris on this point too, that a lot of scientists rushed to rule out lab manipulation early in 2020. So some of them even said things like, I ran 10 minutes of machine learning and I can now rule out all genetic engineering. I think that's amazingly confident, but not super useful to tracking the origins of the virus. And since then, they've had to backtrack those statements.
Why, in your view, and this kind of ties in with a subject we're going to touch on momentarily, what would lead a scientist, especially that early on in the virus's history, early 2020, let's say, what would incentivize a scientist to make a declaration like that so brashly? Who in their right mind, not to be too presumptuous in my phrasing here, but would brag about, I did 10 minutes of machine learning and I can say with full confidence that this has not been touched by human hands? I mean, what is there to gain, in your opinion? What is there to gain by ruling out something like that? And this kind of leads into a larger question of why some scientists, not to mention governments and politicians, but why some scientists have seemed to want to rule out certain either origins or genetic details or hypotheses around the virus. Why are some scientists so quick to want to rule out origins when, as we discussed earlier, one of the most important things about being a scientist and doing scientific research is leaving yourself open to the possibility that you just don't know yet?
So I think a lot of scientists are still human, myself included. So uncertainty is very troubling to a lot of people. When you get asked the question, especially scientists, they love to be able to answer the question. So when non-scientists come to us and ask us, has this been genetically engineered? A good scientist would say, not as far as I can tell, but it's still a possibility. But some scientists want to be able to say that they know. So they'll say like, yeah, I ran my machine learning algorithm and I can tell it has not been engineered. Or some people will say, this is not how I would engineer the virus, so it has not been engineered. So there's some human nature at play. So some urgency to satisfy a query. In early 2020, there were speculations about this virus, SARS-CoV-2, being a mutant splicing between HIV and the coronavirus. So there was a preprint released by Indian researchers claiming that HIV inserts were in this new coronavirus. So scientists were trying to slam that down, to immediately debunk it. And I think the pendulum swung too far. So in their rush to shut down these really dangerous speculations, they went too far to the other side and ended up saying that there's no engineering in this virus. So that's another more innocent explanation of why scientists were rushing to shut down any speculation about a lab origin. A slightly more ulterior motive is that if this virus is truly found to be from a lab, there are going to be very severe consequences for scientists, but especially for scientists who study viruses, so virologists. So imagine if this pandemic, killing 3.5 million people, shutting down economies in many developing countries, is found to be from a lab, from scientists. We could be like mobbed, we could be pitchforked. So I think inherently scientists have some incentive to wish that this wasn't from a lab, to wish that this was natural. And if you keep wishing that something is natural, then any new evidence that comes your way, you tend to try to rationalize it as evidence for a natural origin rather than a artificial origin.
I can understand why they would feel that way, right? Like no one wants to be blamed for a disaster, but if that is their motivation for, and not just Chinese scientists, but scientists in general, it sounds like you're saying, if that is a leading motivation for why scientists seem so intent on writing that theory off, at least they did for the last year, wouldn't that feeling, that gut feeling they're having of, oh man, I really hope that it's not this because of the ramifications that could mean for my entire industry, wouldn't that feeling then motivate action on the safety protocols we were talking about earlier? I mean, it would be akin to if there was a group of people living in a house, like a house made predominantly from wood, and every night they would have a bonfire in a trash can in their living room. And they didn't have any fire insurance. And they were just doing that night after night after night after night. And then one day they came home to see that their house had burned down. And they were really hoping that it was like a lightning strike or something else. Because if they discovered that it was in fact a garbage fire that they'd lit the day before, that they might be culpable for incompetence. But you must understand the connection I'm trying to draw here, right? Like the fear that is motivating them to want to rule out that hypothesis should be, even if it is a natural origin, that feeling in their gut should be a motivation to clamp down on safety protocols moving forward.
Well, I'm worried that some scientists think that if they start introducing more biosafety and biosecurity measures, that it will look like they think it came from a lab leak. So that might be one factor that also prevents scientists from actively calling for regulations right now, because they're afraid that if they start trying to get rid of the garbage fire, that it will look like they're culpable.
Yeah, I man, it's just, I think that the flabbergasted nature of my stuttering is more just coming from the idea that I think the average person, right, the average non-scientific person without degrees from prestigious universities, right, I think that we want to, and this leads almost directly into our next topic. I have one more question about gain-of-function research because I want to end that topic on a silver lining, but I would be remiss not to just mention this. The average person, when they think of scientists from prestigious universities, wherever they might be, right? MIT, Stanford, Harvard, et cetera, we assume that with that background and prestige and access to amazing institutions, that with that comes a higher level of responsibility, sort of in the same way, and this is not a direct correlation, right? But in the same way that we want to imagine that our police officers are held to a higher standard in terms of use of force, because we understand that with their position and their training, hopefully, comes a certain level of responsibility, that when that use of force is misused, we feel betrayed. And so the stuttering you're hearing, and I'm not going to, even though I usually cut my stuttering out of these podcasts, I'm going to leave it in because it's relevant here. It's alarming hearing you say this, right? Because, and obviously this doesn't speak to you. You seem like an incredibly thoughtful person. You've been researching this very carefully over the last year. So obviously not every scientist is like this, right? You are clear evidence that that is not the case. But it seems like there are enough scientists in the community that are either motivated by not wanting to look like they're to blame or motivated by fears of what the repercussions might be, that they're not taking a very serious topic as serious as they should be in regards to safety. And so when the average person like me, who is not familiar with this field beyond what I read of your work and a few other sources, hears the things that you're telling me about what might be motivating these scientists to not act in the best interest of the wider public, it kind of freaks me out, if I'm being honest, because I kind of feel the same way when you hear about police corruption. You just expect better from people who we entrust with public safety. And what is this very topic, if not an issue of utmost public safety? Am I making sense here?
Yeah, I think that's a kind of scary but appropriate parallel to draw as well between scientists and police. And that's why I feel so strongly that scientists have to co-lead, at least be part of the driving force for better science, for safer science. So I really dislike that so many virologists are downplaying the risk of a lab leak resulting in a pandemic. I think it's harmful in the long run when people look back at this and say that, you know what, these scientists were not taking it seriously. They didn't really think about human life over their research.
Yes. Okay. So I've been teasing the next topic. Before we get to it, just back on gain of function research, because if the average listener is anything like me, they've just recently been exposed to that phrase. They probably heard it in terms of fear mongering from either American senators or news sites that they're reading. And it can seem very scary, right? Like it's some inherently nefarious thing. But I know that you know that not to be true. So I'd love for you to just help us widen this perspective. What are some of the positive benefits of gain of function research, and how have these benefits manifested in our lives already?
Yeah, so the first thing is that there's a whole gray area of what could be gain of function research. And a lot of that experiments that are routine in virology labs. So the reason why many scientists had pushed back against a ban on gain of function research was because the term was so nebulous that to ban it could mean banning all of virology. And that would be bad because the study of viruses is how we come up with therapeutics and vaccines. So there are clearly many stages, different levels of experiments that are essential and have to continue to be done, even if they need to be done at a safer level. There's only a very small bunch of experiments that are clearly gain of function, the type where viruses are being made more transmissible or more severe in the disease they cause. For almost no apparent reason. So those, I think there are many scientists who can unanimously say that these experiments are producing a natural risk and putting us all in grave danger. But the majority of the virus research that's being done is actually beneficial. Like if we didn't have this research, we wouldn't have all the vaccines that we have today. Like we would still be being killed by smallpox and polio and things like that. So I think it's important to draw that distinction that gain of function is a really loose term. And a lot of research could potentially fall under that term.
Yeah, that makes sense. I don't know if this is a perfect analogy, but it would kind of be like if all of a sudden there was a spike in traffic accidents due to either drunk driving or some kind of belligerence, right? And all of a sudden you heard like senators or Congress people all of a sudden talking just about how driving is dangerous and we need to ban driving, and it's like, well, look, driving can be dangerous, but driving also allows us to drive our kids to school and get to work and go to the grocery store. And so I think you made a very good point in that if you start using a term that can be so broadly applied, as you've said just now, it's really important that when we talk about banning a thing, we want to make sure that we're actually attacking the harmful stuff like drunk driving and not banning a parent's trip to the grocery store to feed their kids.
Yeah, exactly.
So looping back to the opening of the show in which I referenced Facebook recently lifting a ban on posts relating to the lab leak hypothesis, you've said in past interviews that our media and our scientists went too far in discouraging or even stifling views related to the COVID lab leak hypothesis. You said, quote, "When that happens, we are left unprotected against a future pandemic," end quote. And so there's kind of two concerns that I have here, right? Or two concerns that kind of affect our society. One is of self-censorship, right? And the environment that is leading scientists to self-censor, either through direct or indirect pressure. And how do we encourage a culture of inquiry, a pursuit of truth, and a feeling of safety for people within the scientific community so they feel they can speculate on hypotheses that may be currently unpopular or even share with the public uncomfortable or inconvenient truths? because we kind of been dancing around that topic throughout our entire conversation. We just touched on it. This fear that some scientists may have that they'll be held accountable, right, in some strange way for what happened with COVID, or they feel that if they say that it could have leaked from a lab, that they'll look unserious or they might run afoul of a social media ban. So how do we encourage scientists to speak more freely and openly? And how do we create a culture in which that's possible?
I think in this particular case, it was extremely difficult due to politics. So the moment politics came into play, it made it impossible for basically all scientists, because many scientists see themselves as Democrats or liberals. So the moment Trump came out as saying that this came from a lab, this virus came from a lab, that immediately nobody wanted to be associated with that. And all of the news outlets and even science journalists started to pile on saying that this was a conspiracy theory, that only unhinged people think that the virus is from a lab. So in that kind of environment, no scientist felt that it was safe to speculate that this had come from a lab. In fact, I think I was extremely naive when I first put out a preprint with a single line saying that this could have come from a lab accident. What has made it safer now is that the administration has changed. So Trump is gone. People are no longer worried that they will be seen as a Trump supporter. I recently co-signed a letter with 17 extremely prominent scientists published in a top scientific publication journal, Science, saying that we need to investigate both natural and lab-based origins. And so now it's much safer. Although it's not completely safe yet, there's still a lot of people calling it a conspiracy theory, but it's now a lot safer.
Yeah. I mean, that all makes sense. But previous guest of the show, Sarah Mojarrad, she's a science communication educator and advocate, and she spoke about the importance of clear, truthful, and consistent messaging in the fields of science and medicine in her episode in order to gain and keep public trust. And I understand the many factors, Trump, et cetera, that were at play that were making that difficult. But, there's been a decent amount of mixed messaging around many different topics relating to the pandemic over the last 16 or so months, right? The efficacy of masking, the effectiveness of vaccines, what's the right amount of social distancing, how at risk to the virus are children under 12, and so much more. So, anecdotally, I know that even some of my most well-informed and curious friends find it hard to keep track of what's real and what's not real, what's true and what's false in topics relating to COVID-19, relating to the pandemic. So what are some ways going forward on both the individual level of the scientist and the systemic level of the scientific community at large that we can ensure that critical information is more reliable and consistent moving ahead, right? While acknowledging that things were difficult last year, what are some best practices on the individual and systemic levels that scientists can do to regain public trust and ensure that they're communicating clearly and truthfully?
Well, I think it takes apologies. So many of these COVID-19 topics have been extremely controversial, and I think driven by a need to be certain. So when the public asks, do we need to wear masks? When the public asks, do we need to stay in well-ventilated areas because this could spread by air? A lot of scientists like to give really certain answers because even as scientists, people have trouble dealing with uncertainty. They have trouble saying, I don't know, or I'm not confident in my conclusions. So that has to change. I think there has to be increased communication of uncertainty, of a lack of confidence. And some of that might have to come in the form of apologies for past communication errors. So things like top experts saying that don't worry about this, it's not as bad as the flu, or some of them saying don't need to wear mask. They need to go back and explain why they made those decisions, why they conveyed that kind of confidence and certainty in a time when they could not have that kind of confidence and certainty. And I hope that the public and non-scientists can understand why some scientists made those mistakes. With regards to safety of other scientists speaking up, I think this is an extremely complex situation, not just because of the politics at large in society, but also because of the politics inside of science. Is that if you a proponent of a very unpopular hypothesis, you could get censored, just not because of any one or group of malicious individuals, just because nobody wants to help to platform you. So Twitter is one way around that, and I've benefited a lot from this, is to bypass the gatekeeping and go straight to Twitter. And then a lot of scientists have expressed great concern about that, about preprints and Twitter being a way for the gatekeeping to be bypassed.
Yes. I mean, that's entirely how I discovered you in the first place, was through Twitter. In an age before social media, I think it would have been a lot harder for folks like me to find scientists like yourself. And it seems like, going back to your point about how scientists need to be more comfortable embracing the uncertainty of science and of knowing whether something is true or certain, there has to be some responsibility within the media as well. Going back to the very beginning of our conversation, I cited something that you said is important for people within the media and journalists to ask scientists, which is not just what do you know, but what don't you know yet? And so it sounds like some of the responsibilities on the media to also embrace that uncertainty and to kind of like set the volleyball up right for the scientist to spike it successfully is to ask those questions that plant in the audience's mind that, hey, science is a process and scientists aren't going to know everything all the time. And in that way, it can kind of give scientists permission, right? As opposed to, what do we know? What are the percentages? What are the chances, right? Which kind of puts a scientist understandably in the hot seat and they're on camera, in front of an audience. It kind of puts them in a position where they have to act certain in face of uncertainty. It sounds like a lot of the onus is also on the media to set scientists up to allow them to express their uncertainty in a way that allows them to update information as it changes. Is that right?
Yes, I do think that scientists and science communicators and journalists have to work together to make sure that uncertainty is not penalized. So in the past year, I've interacted with some journalists who really want you to give them a number, who are like, why aren't you confident about this? Look at all these other scientists who have given me confident answers. And I say, that's bad. That's bad in a situation where there's so little evidence and so many scientists are being compelled to give you confident answers so that you can have a good soundbite, so that you can have a headliner. Journalists have a responsibility to be responsible, to communicate science responsibly. So they need to be educated too. It's not just the scientists who need to be educated, but also the media. They needs to be educated.
Yeah. I mean, to dance successfully, you need a good dance partner, right? Alina, Dr. Chan, I want to thank you for your time. And I want to ask you the question that I ask every guest on this show. And I think it is relevant to some of what we've been talking about today. I mean, as you've said, scientists can often find themselves in a bind, right? Where they're pressed for certainty in an uncertain world, and they feel a lot of conflicting pressures on themselves, either a fear of misguided responsibility or a fear of a hammer coming down on them for whatever reasons around safety protocols or research protocols, et cetera. And I think we need to extend empathy to people who are going through that. So in that spirit, I ask you this question. As individuals, we're limited in our time, in our energy, and often in our capacity for empathy. Even the most well-intentioned and caring person can't be thinking of every person, every group of people all the time. It's just impossible. So, is there someone or a group of people in your life or in the world at large right now that you would like to take a moment and offer empathy to?
Yes, it's virologists. So the scientists who are in this bind right now of struggling to think whether they've been right all this time, that viruses spill over from nature all the time and we should be on the alert, or maybe that one of their own made a mistake so bad that now millions of people are dead. So I don't think that they should be penalized. What we really need to do is to remove the blame so that we can have a very productive conversation about how to move forward in the future. So I understand the fear that there will be a huge wave of hate coming from the public if this is ever found to be originating from a lab leak. But even in this current moment of uncertainty, I want the public to remember that this was not intentional, right? So this was an accident that no one really predicted. So I have the most sympathy right now for the scientists who are in this bind of whether was it really like a mistake that one of us made and now millions of people are dead.
That's very well said. And I think that's important to keep in mind. Alina, I want to thank you for the time you spent with us today, for the information that you've shared with us, and especially considering how contentious this hypothesis was for most of the last year, how in headline after headline, in major reputable publications, this was repeatedly said that the lab leak hypothesis was a debunked conspiracy theory. I know that it couldn't have been easy, especially during the height of that, to continue your research and to continue looking into this hypothesis when there was kind of just so much wind in your face, metaphorically. So thank you for keeping at it. I'm really glad that I came across your work, and I look forward to reading more of it and seeing where all of this goes. So thank you so much for your time, and thank you for the work that you're doing.
Thanks for interviewing me.